I show this next thing now. Yeah, so I think we can go over sort of the quick stuff first and then get into the closure side stuff. I think it might require quite a bit of refactor, and I don't know too much about it. So yeah, let me share my screen or just send you the link to the blog post that Roxanne and I were working on. So I can see the status sync channel on Zulip. I'll share my screen just so it goes on the recording. How do I do that? Probably would need, yeah, I would need sharing permissions.
Oh, okay. Your host now.
All right. Okay. I think it's this one. Yeah, it's this one. Okay. So basically what, no, not, one sec. How do I get rid of the zoom thing that shows? Okay, I suppose this works. So what we had talked about was we wanted to take the blog post and split that into like pages that will go in the Ross reference. So that's what we did. So we have 2 pages now, which are now actually probably this is easier. So there are 2 pages now that will go in the Rust reference, and then there are blog posts that will end up linking to them. So the overall blog post now is just sort of a brief description that we talked about that we want to give about the feature and the fact that just give an idea that this is going to be a breaking feature. So they're going to migration helps, goes a little bit into what are closures and really just ends up linking the Rust book, Rust by example, and the Rust reference, depending on the level of the experience the person has who's reading this. Gives a bit detail into what disjoint capture is and kind of links the RC so that whoever cares about like knowing what the motivation is and all that stuff. And the plan is over here, we'll end up linking the posts, our pages in Rust reference, which says one is there are cases where what you like the path is not captured to full precision and that there are minor breaking changes. And this is there again documented in the Rust reference. Details on using the lint and the that and bugs. And then
seems good.
Yeah. So and then just details into each one of these cases.
I'm wondering. Okay, can you scroll back up to the 2 reference pages? What's the difference in them? I see.
So one of gone, sorry.
Well, the first one is changes to semantics. That's more like when do you need migration?
Exactly.
Okay, so this I think should also go
in the migration
guide. Yeah. And one nice thing is, so if we put that in the migration guide, that'll be available immediately in the nightly links. The Rust reference only contains stable things, which is kind of annoying. I wish there, I don't actually like that. I think that's, well, it makes sense, but it's annoying when you're trying to do what you're trying to do, because it means you can't link to it. But we could land this in the migration guide and link to it the next day via a nightly link. And then for the reference, I guess we could link to a PR or something. It's fine.
Okay, makes sense. I see why you said a PR in the Rust reference now. Yeah, Rox and I were a little confused when we were reading.
Yeah, that's probably why I said that. I do think it's a good idea. So scroll up. One thing that's not in here under capture precision. Sorry, not that far up.
Okay.
Looking. I don't think this covers the case where you're dereferencing a reference.
we did talk about it. Here.
I'm trying to see, is that really all the cases? What about a box, for example?
Okay, I can put a box example if you want that.
I think like
Maybe.
box and RC.
Okay. I will. Let's see how you add comments here. Okay.
Like, I guess what I'm saying is there's a rule in my head, which is that a move closure will never move anything that wasn't on the stack.
Yes, it is if a move closure will not move out of a reference. Is really
Right.
what that rule is. So that is, yes, we talk about it, that
Well, it's
moving
not
through
only
the,
that, because box is another example.
yes,
Right.
okay, fair enough, fair enough.
I think the rest does fall out from capturing references because RC, it might be worth adding a note about adding an example of RC. I would probably put it as like it's not a rule. It's an example to work through
Mhm.
because
I see.
basically, because what happens is the deref of the RC gets desugared into, into this ampersand, into this call to the deref method. So from the
Mhm.
compiler's point of view, it's a borrow of the variable. So like,
Okay.
it's just using the existing rules, we can kind of
Explain RC.
I think the ideal for me would be like, it's a move closure that borrows some data that's inside an RC that's in like A.B or something. And so what winds up happening is you can kind of show the capturing, you can show a few things here, right? Like first it desugars to a borrow of A.B, which maybe if it's a move closure that passes through a reference, I don't know, maybe you can show that then the capturing reference in move context might apply in that situation. Does that make sense?
Somewhat. A move closure containing an RC. I suppose at that point we would also need to say box are special cases where the deref is. I
Yeah,
suppose.
I think you should just say, have a section on move closures in box because box is special right now because of deref move.
Yeah. Okay.
But I think we would expect in the future that other kinds of moving would act analogously.
Okay. So yeah, this is basically split up. The blog post is kind of nice and small now. And
Yeah, it's great.
second thing we wanted to discuss, and it was also related to the edition guide created, and that there was discussions about. So one thing that we had talked about was annotating the Rust standard library with insignificant destructors. So how do we want to go about that? Is there like what kind of formal process is, or A, how do we plan on documenting all of that? B,
I think this would also be good material to include in the guide.
mhm.
And possibly the reference. I think.
Is that something?
So,
Is that just? Oh, okay, sorry, go on.
well, I was going to say, what I would like to say is that we should come up with a rule of what we believe to be insignificant. And for me, it's probably freeing memory. So any drop that only frees memory is a candidate. Probably a good idea is to ping the libs team and see if they have any other suggestions.
Okay, I will.
I think some obvious candidates would be vec drop, vec string, and hash map, kind of container types like that.
Yeah.
And then I would think that the next thing I would do is there's two approaches. Either we go through all the drop impulse in the standard library and we look
Kind
for
of.
those, systematically, which may not be that bad. There may not be that many. Or else we another approach is we turn on the lint on the compiler
Right.
and see what we get.
That's
Uh,
not a bad
and
idea.
maybe that'll take us to some, maybe we'll see something that we missed and say, oh, that's obviously not significant, for example.
Yeah. Okay. Yeah. So I think those. I suppose. I don't know. Do you have questions? Because I know you're.
No, that makes sense. I think
Okay.
when we were talking about, we were also thinking of enabling the lint.
Okay. Yeah.
I think what I would do is start with the easy ones, the collections,
Mhm.
run the lint on the compiler, and see what you get, and see if anything sort of jumps out at you as like, this is not just freeing memory, but it's still seems insignificant. And then
Or
we
has
can,
any side effects of any sorts. Yeah, like flies.
right, sort of my goal here is like, before we probably do want to go through the drop impulse one by one eventually, but before we do that, it's probably a good idea to have an idea what the rules are that we're looking for, so we don't have to do it more than once.
Yeah, sounds good. So start with the collections.
Yeah,
I'm just gonna leave a note in our status thing as well.
another one that you might find. No, yeah, I was thinking, I know that some of the iterators like drain or into iter, vec into iter have, will free memory, so that might be another candidate.
Okay. Yeah. So I love these notes and these.
I'd hold off on pinging libs until we do the first, like until we feel like we
Confident.
have a good suggestion,
Yeah.
and we can give them the data. I'm 99.9% sure they will agree with the basic idea, but
All right.
I guess we could just let them know that this is what we plan to do in case there's any immediate objections.
Yeah, it might be a good idea to get a first. Just we are planning on going with the strategy.
Right.
Okay, I'll draft them and I'll send this to. Okay. I'll
they may
type
have
this out after.
they may have good suggestions.
Yeah. So okay, closure size. So I looked into some of the increases that we saw, and like one of the interesting ones were. Let me change what I'm sharing once I figure out how to do that. Oh, new share, I see. And, okay, that works. Let me know if you want me to zoom in a bit more, which I probably should. Okay, so the closure size went up from 40 to 48. I suppose you can, there's up there. And I should probably also open the source file just so that it's easier to look at. So that was, yes, this function. What gets captured by this function, at least from in terms, is so we're looking at this closure, which is over here, which includes this nested closure within it. Package ID, kind, filter, unit for, and self get captured by this closure. What's interesting is before the feature, what's get captured is this reference directly. And same for, I think, the function. This gets captured directly. What gets captured after the feature is a reference to dereferenced self and reference to dereferenced filter. So when I outputted the types of these things, I see this double reference situation because a reference is being borrowed by a reference in the original, like pre-229 implementation.
Yeah, I see.
And again,
okay,
over here.
Okay.
So
interesting. And what's this impl on? Is it impl on state?
It's impl on state, yes.
Okay. Yeah. So the problem is that it's now a fat pointer instead of a thin pointer.
Yes. So I do not know too much details about that, but what's the difference? Is this just the size of the pointer that's different now? because function
Yeah.
pointer versus.
If you have a reference to a din type,
Mhm.
like ampersand din, then
Mhm.
that's actually two words. One is the pointer to the data, and one is a pointer to the V table.
Okay, that makes sense. Yes.
And then if you have a pointer to din, then it's only one word because
It's just
like
with
one word
reference
that
to the
points
two
at,
words.
yeah,
Two words.
exactly.
Yes.
So it's worth noting that star, like capturing star of a reference, if you don't do anything else afterwards, doesn't actually narrow the set of things that are borrowed, right? So if,
Yes. Exactly. Yes.
yeah,
Exactly.
because it's kind of all the data.
Yeah.
So you could certainly imagine us filtering that out, sort of taking
Yes.
off any trailing stars, so to speak.
Basically, like just to write it out, if we have ampersand star, ampersand being well, more like this being captured, then we can just reduce this to the ampersand whatever.
Yeah. Well, is that what's happening here, right? So you've got, I think you've actually got ampersand star star, or
I'm pretty sure we have ampersand star. I can confirm that real
can
quick.
you show like,
Yeah, I'll show the capture analysis.
yeah,
One second. Where did this go? Okay, sorry, I think I opened the wrong file.
because a single ampersand star is kind of a no-op, that's why. But you've removed one level of indirection.
I think I cleaned right before this, or I'm not sure what I did. Maybe people looking for one second. Oh, this is not with the feature enabled. So if I scroll up, I might just have this. Yeah, this is. Oh, I do have this. This is pre-feature. Oh yeah, this is the post-feature one. So yeah, filter is being borrowed by filter deref immutable borrow. Oh, but our filter itself is an ampersand reference. So ampersand star. No, it's ampersand star ampersand.
Okay, so filter is an ampersand ampersand. And we're
Filter
borrowing.
Let me make sure filter is an ampersand ampersand or not. I thought it was just an ampersand to a den type.
I see. No, you're probably right. Yes, that makes sense.
Okay.
Okay. I see what's happening. So before, right, okay. So here's the trade. Yeah, that's interesting. So we're adding a layer of indirection in exchange for a smaller closer.
Mhm.
I see. Yeah. I mean, the way I'm thinking about it is basically, I think you could remove any number of stars. Like you wrote one there, but
Like if this was a set of like star ampersand star situation, or
no, you can't have more than one ampersand in there. So there could be any number of stars there though.
oh, I see. Wait, can there? Wait, this is
Like
valid?
that. Well, there would have to be a corresponding number of ampersands in the
Okay,
type of the
yes,
thing.
yeah,
Yes.
okay, yes, exactly. Yeah.
And you could just kind of strip them all and you would get back to however many there are, you could strip them and you would kind of get to the older semantics. You see what I'm
Will
saying?
we? I'm not sure. So
However, I think it's better. I only think it makes sense to drop the star if it's a fat pointer. I don't know how much we care about this.
like this is the new one, right? So we had a reference to our ref ampersand, like we have t is where the den function pointer is.
Right.
So we have this ampersand t, we do a dereference, and then we put an ampersand. What we get back again is, if we remove that star, is we get, wait, you're just saying remove the star and not the ampersand with it, or
That's
with the
right.
ampersand. Oh, I
No,
see.
no, you can't remove the ampersand. I mean, the star kind of removes the ampersand, so to speak. I'm
Yeah,
saying
so
you
this,
can remove the star,
okay.
and that's what you're saying too.
Yeah, but if I remove the star, I lose this ampersand, which gets us back
No.
to the same.
No, you don't. What do you like? You can't remove that. Hold on. So instead of ampersand t, I think you should put like x colon ampersand t or something,
Oh, I see what you're saying.
and then put the
Okay.
star. That's what you actually have, right? You're borrowing an
Yes.
x which has this type. And so what I'm saying is, anytime that you have, we can ignore the leading ampersand because that's more the mode by which we borrow.
Yes, this is the mode.
And we already, it has to be some kind of reference mode because for moves, we already truncated at the star, right? But what I'm basically saying is any I think of it as trailing stars, but in this notation, they come first, like the outermost stars. You know, if you make this as a tree, you have a star with a child of X or something. Any of those outermost stars you can drop and you won't cause new borrow check errors. That's what I'm saying. Because you're already sort of,
it doesn't affect the precision.
It's all the content, right? It's all the content of the reference. Now, if
Exactly.
you have a dot, if you have a field coming after it, like if this were in parentheses and there was a dot f, then you can't drop the star because then you would have to drop the field too, right?
Yeah, I think that makes sense. I had implemented that actually at some point in the past. 1 second. I have performance. I have performance related, like speed perspective. Let me, I don't remember the exact numbers. Give me 1 second. I'll pull that up.
So I think this can only make the size of your closures smaller. I was trying to think if there was some way to get the closure bigger by dropping stars, but I don't think so. Because you can't star through basically you can have a thin pointer to a fat pointer like we have now, and you can star through the thin pointer, but you can't have a fat pointer to a thin pointer. Like that's not a thing.
No, that makes sense.
Or at least you could, but or if you did, it would have to be like an overloaded deref or something, and we wouldn't do it anyway. So, so it's strictly going to make your closures smaller. It might make them marginally slower at runtime. There's an extra load.
Yeah.
So it might be worth only doing it, you know, if the outermost thing is a fat pointer, then maybe we want to.
So there isn't too much. At least this was what I did back in November, December. So this was whatever our closure restriction was, and we remove our trailing derefs.
Yeah, I mean, we could do something where we say if the type that we're borrowing, if there are trailing derefs and the type which we're borrowing
is a fat pointer,
is a din type,
okay,
or is not sized in the general case, then remove a trailing deref.
Okay, let me write that down as well.
That's probably the best behavior, because that it seems better to borrow ampersand state than ampersand state. That's kind of dumb.
Remove trailing deref as the trailing.
At that point, it's kind of an optimization. I mean, well, it's not kind of, it's literally an optimization.
It's an optimization, yes. So we have this, okay.
So we can, yeah, you can sort of imagine that I don't know, to the extent there's a spec.
Yeah.
I don't know exactly what it would say here, but
Okay. Yes. Now I want to talk about profiling generics because it is.
I have a question before we do that, but which is you had previously talked about an optimization for if we capture all the fields.
I still have not tried that just because I do not have complete profiling. I don't have my profiling set up completely
Yeah,
for
so
it to make
you don't know how worth it is.
how worth it is. So I want to do that first. And one sec, I did send a message about the, I probably should have links somewhere in all of these. Also, I'm sharing, wait, what am I sharing right now? I'll share this. So, where was, I think David replied to this a little bit. Give me 1 second, I'm trying to look for it. Okay, yes. So, okay, I don't see this here.
Yeah, I don't really think the reference to polymorphization made sense.
So, okay, so what I was trying to do is we have this. So what we discussed was we have this function which is like create mono items.
Yes.
And what we want to do is we want to basically polymorphize our closure and um, essentially see the size of the polymorphized closure, right? At least that's what I understand we were trying to do. Sorry, monomorphized, not polymorphized closure, which is
Yeah,
like,
I think the polymorphism is sort of a distraction, but like that's just an attempt to remove unused generic parameters, which
okay,
is fine, but I think we can just ignore it for the time being. Like it probably doesn't even trigger for the code we're talking about.
okay, so that if that's the case, and this might be doable because what happens is, so I have two different types, right? I have the type after the closure and I have the type before the closure. So before is fine because it's sort of what's currently in how the data is pipelined, but the way the polymorphism code ends up working is, and I do not have a link to it here, is it depends on the def ID and everything is, it does all the calculations based on def ID. So
uh-huh.
either
So
I write it,
are you saying the polymorphization code is interfering with you?
I think so. It's less that it's interfering. It's more like I would like, it's difficult to make it work on two different types associated with the same definition ID. So 1 second, I'll just go to,
Okay, I think I understand. I don't think this is at all relevant. I think you could just comment that code out for now.
would it not cause problems with anything else?
I don't know.
Okay,
I doubt it, but it
all
might.
right.
I think what that does is where we would have generated 2 monomorphized copies, we only
Mhm.
make 1
Okay,
because,
I'll try
or
that
like
then.
we would have generated n, we only make 1
Mhm.
because we see that, that generic type parameter is not relevant.
I see.
I think if we don't have that line of code in there, we just will make n again.
Okay.
And I think that's fine for your purposes. In fact, it might even be better.
So one thing that you had
You could
previously
ask
mentioned was,
David TWCo if there's an easy way to disable polymorphization. There might be a Z flag or something.
oh, so one thing that we had discussed was we want users to be able to submit profiling data, or
Yes.
so I do not want to do, like, my point, like, kind of was either we give them a different version of the compiler that they submit, which is kind of non-ideal, which is like, again, it's available on Rust up, but
I see your point.
yeah,
Yeah, we don't want that. We want it to be the standard one.
yeah.
Let me look real fast at that polymorphized code.
I'm
I'm
going to
pulling
try
up.
to find the code I was talking about.
So you can actually disable polymorphization.
Mhm.
with a command line flag. If you
Okay.
if you go to instance.rs,
Yes, I am. Okay, let me share my screen. I am there.
I don't have your
Yeah, I'm working on it. Okay, yes.
trying to pull your.
Oh,
You're not on. I
it's
can't.
probably on a different
It's on a
display.
different
That's
desktop, and I'm trying to figure out how to. I don't.
uh,
I don't know how one gets
I
over
can
there.
I can I can stop
There we go.
sharing
I
the
figured it
screen.
out.
All right.
Okay. My doc is so full of garbage. It's hard to find it. So. Okay, where are we here? Yes.
I'm
So
in the
there you are.
polymorphize.
Wait, that looks different.
There's this function which is polymorphize, which calls this polymorphize.
Yeah, go up to the function on there. You see that if right there on if not.
Yeah.
So what that's saying is if this flag,
Oh, it will return as is.
it'll just return as is. You could probably make that change that if to like, or if we added a -z flag that was like analyze closure size,
I see.
we could just change this to say if polymorphization is disabled
Mhm.
or we're analyzing closure size, return self, and it should be
All
fine.
right, that makes sense. And is there an easy way to? Well, I can probably look into this. I forgot, and I might have. Sorry, where's that function? Of creating an instance within the. Sorry. Where did that go? Sorry, I will.
You-
F mono. What is the name of? Yes, this one. Create FN mono item. Is there a way to create an instance over here of like a type that I want? Like instance on the fly? Like right now instance is passed in, but I would have to create an instance
Why?
myself
What for?
because so I need an instance of the type that is before and an instance of the type of the
But
closure that's after a
I don't.
feature.
Yeah, but instance isn't really what you want. I don't think. What's the code you've
But
written actually? Like
sorry,
instance is like a resolved form of a method or something.
I
But
see.
I don't think it's what you need to measure the size.
Uh, so wait, doesn't polymorphize remove and like so at least when I did this a couple days ago, again, I would probably have to change when I'm sharing again, is I was getting the same issues if I did not call polymorphize on like as I'm not okay. I'll share my screen. Sorry, I have like this mismanaged into different places, but so what I had in earlier was I would polymorphize the instance and I'll read the type of the instance and do the size. I would not do this for the new instance because I did not have the
Right.
it's
But
like not monomorphized. Yeah.
right.
So I will end up getting the same error as before, which is failed. I do not know these types, and therefore I can't give you the like the size of the closure. I think I figured this one out, but right now if I move this back to mirror, I don't get this error. So
Go back to your code for a second.
Mhm.
What is the closure size eval? What is the new tie that's put in there?
New tie is the so I create two. Okay, so in write back or like in type check, I create the closure type, which is would be after the feature. I just store that. I just create that as a like I create a new closure type and store that information. What would the type have been if the feature was enabled? And I'm accessing that type here.
But what does it look like?
It's exactly just a by closure. It's exactly the same, just the up part types within them is different than what they would have been if the feature is not enabled.
I see.
So just to
I
make
wonder
it
if that's causing a problem because like I think the problem is not related to polymorphize necessarily. I would think the problem might be that we're not expecting a tuple with that arity. Like it has more or less fields than is expected.
Wait. Oh, interesting.
But isn't a closure is literally the same as a tuple, right?
Closure is a structure and it has a tuple of a vertex. Yes.
So can we just, instead of making a closure type, can we just make a tuple type with all the upvar types in it
We
and
can
get the size of that?
yeah, we can do that. I can try. My question is, even if we do that, nowhere in the pipeline am I saying, okay, these are the concrete types that are associated with that closure. Because if I have a function, if I have a generic function that contains a closure, there's only, at
Oh,
least
well,
the
you
way I
have to
understand
apply
it,
a substitution.
exactly, that's not
Oh,
happening,
oh,
right?
okay. Well, that's easy. Yeah, yeah.
Okay.
So what you want to do is take the new, I see your point. Yeah. So new tie here,
Mhm.
before you call, like
Size of
after you
layout.
fetch it out of the type check results,
Mhm.
you need to do let new tie equals new tie dot subst. Open
And
up the type of instance. Instance should have a subs or something. I don't know what
okay.
it's like
Relative.
exactly, but
Okay, one sec. I have instance. I'll just open it here. One sec. I need to look up where it is.
yeah, you could load it in the Rust doc. That'd probably be
Okay, that's probably
easiest.
that is good idea. All right. Which instance? I'm assuming. Yeah, I think it's this one.
That looks right.
Yes, it contains the subs, right?
Yeah, so just do a subs with that subs. Do a
Okay.
substitution with that set of substs on the new tie variable that you have.
Is there a function that does? I'll see how this works. So is it just okay? There's this function. Okay,
Well,
that works.
wait. But that doesn't do quite what you want. I mean, you want to do you don't want to actually call this function. You want the function that's on line 101. You want to inline.
Yes.
Yes.
Okay. Like this function, right? Yeah.
Yes,
I need
yes.
to do this call. Okay. I see.
Correct. I don't know where the param env is. I think you can just give a dummy one because.
No, that one does not work. At least, so over here in my implementation, I had, where did it go? Wait, I did move it. One sec. Yeah, so in my implementation, I do this reveal all.
Yeah, that looks right. Yeah.
I get this normalizing, erasing errors thing when I do that.
Well, it's probably because you haven't done the substitution yet.
Yes, because I haven't done the substitution yet.
Yeah.
Weirdly enough, I do not get this error when I do this in Rusty Mirror or Rusty build, which is interesting.
Yeah, I don't know. But
okay, this makes sense.
Anyway, if you put the subs there, and I think I would change it to a tuple myself because it just makes me uncomfortable to have a closure type that has the wrong upvars, that don't match the rest of the compiler. It seems
fair enough.
Something might get confused.
Fair enough. Makes my life makes a little bit of the type check code a lot more. Well, not a little. It makes it a lot cleaner to see what's happening.
It makes it a lot cleaner.
It makes it a lot cleaner.
If we use a tuple or if we use a closure?
If we use a tuple,
okay.
Because like for closures, I need to construct the closure parts and then do all the
right. It's kind of a pain in the neck.
Actually, no, we probably don't want that because if we do that, we will lose the parent subs. But I suppose those don't matter because I can just steal that from instance over here.
I don't think you need. Do you need the parent subs for anything? I don't think you need that.
I can just get it out of the instance that is over here because the parent subs for the both new and old closure are still the same. So it doesn't matter.
Yeah, I don't think you need it. I think you can make it a tuple.
Okay, I'll try that and see how that
goes.
Because
it'll have references to some generic types, but that may appear, but it's okay.
Okay. I will
try it and see what happens.
I'll try and see what happens.
Yeah, you can also just try the dot subst. It may work the way it is. So try that first and see if the code is working. Okay, fine. But it does make me a little uncomfortable, but it won't be there forever.
So the difference is if we keep a closure as is versus if we keep a
tuple in there.
Tuple is the percentage increase might look different because right now the closure size probably also includes the size of the closure kind and the other thing, or does it not?
No. Well, I hope
Okay.
not. I mean, I hope those are
Okay.
just dummy variables. I hope we're not actually storing data for them.
Okay, fair enough.
I
Yeah,
you'll have
because
to,
all the
if you look at the layout code, I bet you it's pretty much.
yeah, fair enough. I suppose there's no runtime benefit of keeping that data. It's in. Okay, I suppose maybe this one. It's this one, no? Or yeah. Or no. I'll go with the first one. Yeah, I think this is a query. This will not get me anywhere. Oh no, the. Okay, yeah. So yeah, it just takes the advertise. Okay. I think generator does complicate, and that's what was confusing me. Generator does some things with
Generators
other
are
data.
complicated. Yeah.
Yeah. Okay. Yeah. So okay, I think I have an idea. I'll hopefully have something by the weekend that I'll post up, and we can discuss it next week.
Great.
Yeah.
Our next week, I might not be able to make our meeting, but we can discuss
Okay.
it async. One thing I
All
would
right.
say is do make the flag. I think that's the
Okay.
first thing I would do. Both because you probably want this code to be behind a flag, but also just
Yeah,
so
I'm
that,
currently.
I was gonna say, just so you can turn off the polymorphization sort of uniformly by
Mhm.
doing it in the right spot. I don't know. It could also make weird ices or something.
I can try it out. I'm currently just using an environment variable to do all the checks, which is technically the same thing, just the wrong interface for a user.
Yeah. That's fine. I mean, we shouldn't
So
land it that way, but it's fine for
yeah, yeah,
prototyping.
for testing. Yeah, that's all right. Thank you so much.
All right, cool. Great work.
Thank you.
Yeah, see you later.
See ya. Wait, how do I? Oh, stop share. All right, I'm the host.